How's it going, everyone? Welcome. Eulier Gonzalez here. So in today's video, I want to explore about the objects, how you can define these notations in Typescript, and understand now this notion of merging declarations, which is something that explains why interface and types what is the subtle difference between each one of them. So the docs says that it is based on how these definitions are processed. So when you here, so when I look at this, right? So the difference here, or the most basic concept of definition here, but again, this declaration merging that comes from the reference handbook, all right? It says that it describes the shape of the JavaScript objects, but the concept or the definition of the declaration merging is to tell the compiler, hey, we need to merge this two declarations, and declarations can be either a type or an object or a namespace or enum or even functions and variables. This is quite interesting here. So when you use now namespace, it merges the namespace and the value. But for functions and variables, this is something, for example, as I mentioned here, type creating declarations do just that. Do just what the types. Let's go over this, right? So in TypeScript, a declarations create entities in at least one of these three groups. Okay? So there's a namespace, a type, or a value. Okay. So whatever you use now, a namespace, or a class, or an enum, which is a bag of constants, or an interface, or a type alias, or a function, or a variable, any of those declarations fell into one of these entities. Either is a namespace, or as a type, or as a value. Right? Makes sense. Okay. But again, it is create an entity in at least one of these three groups. Namespace creating declarations create a namespace which contains names that are accessed using the dot notation. Type creating declarations do just that. They create a type that is visible. They create a type that is visible with the declare shape. They create a type that is visible with the declare shape and bound to a given name. Again, so type creating declarations do just that. They create a type that is visible with the declare shape and bounds to a given name or a given identifier. Lastly, value creating declarations create values that are visible in the output JavaScript. Okay, so when you're creating when you use any of these declarations, it will create, so TypeScript create now that declaration that's fell in one of this group. So whether it's a namespace, a type, or a value. So whether it's assign that type to an identifier, or assign that, or lastly, value creating declarations create values that are visible in the output of JavaScript, and then the value is attached to that identifier. So understanding what is created with each declaration will help you understanding what is merged when you perform a declaration merge. So what is merged when you perform a declaration merge? So so merging interface, which is what is this today's video, right? Among other stuff. But merging interface is this. The simplest and perhaps most common type declaration merging is interface merging. At most basic level, they merge mechanically, join the member of both declarations into a single interface, right? For example, like this. So when they have the same name declaration, it's going to merge mechanically into one single interface. But non-function members of the interface, non-function members of the interface should be unique, and if they are not unique, they must be the same type, right? So if they are not unique, they must be the same type. If you define that here later on, right? And the compiler will issue an error if the interface both declare a non-function member on the same name but on different types. And for function members, each function's member on the same name is treated as describing an overload of the same function here. Exactly, but for function members, each function member of the same name is treated as describing an overload. In other words, it's a variant of the same function. Of note, too, is that in the case of interface A merging with later interface A, the second interface will have a higher precedence than the first one. So in this example is here, if they have the if for none. So this is the rules of this merging declaration with the same name. In this case, interface. So if you declare interface with the same name, it's going to mechanically join to create a new one. For non-function member, which is interesting how Typescript define this, functions and non-function members, but for non-function members, they must be the same. They are unique, all right? And if they are not unique, they must have the same type. Okay, but for function members, it's creating now a variant of that, or is treating as an overload of the same function, or in other words, as a variant of this, right? So in other words, what it's going to do in this case is going to create is a new merge interface declarations that contain is both non-member, in this case function members, and if they have the same name with different variations or overloads, right, like this. So the resulting one, as you can see here, in that case, in the interface A merging with the later interface, the second interface will have higher precedence than the first one. So in other words, this has more, so it's going to put all of this at the top, all right, and then the other one, and then the other one, right? And this is kind of interesting because this is how you can define is perhaps several the same functionality but with different use cases. So notice that the elements on each group maintain the same order, but the groups themselves are merged with later overload sets order first. One exception to this rule is specialized signatures. If a signature has a parameter whose type is a single string, literal type, e.g. non-union or string literals, then it will be bubbled towards the top of its merge overload list. For instance, the following interface will merge together. So for example, you have a document, right, here, and each one of them has a function members with the same declaration. The docs say that it's going to now organize all of them based on the last declaration has precedence. So if we're gonna put this at the top, right, the canvas and the string, and then the next one at the top, the span and the diff, and then okay, in this case not. One exception to this rule is specialized signatures. Oh, specialized signatures. If a signature has a parameter whose type is a single string literal, all right, um, type union, AJ not a union or a string literal, it's a single string literal, then it will be bubble, then it will be bubble toward the top of its merge overload list. So in other words, this will bubble up to the top of the ball of that. And this another one. This is specialized signatures, like single string literal, not union, exactly, not union of a string literal. Only one single value, or only one single literal type. Okay. Okay, and the resulting declaration is this. So this is one of the behaviors of interface. All right, merging interface. In model augmentations and global augmentations, and the basic concept of this. So that's good for interface. All right, so that Typescript, anytime that it finds declaration with the same name, it will for example, exactly, it will try to create a new definitions on that. This merge definition has features of both the original declarations, exactly. This merge definition has the feature of both of the original declarations. Any number of declarations can be merged, and it is not limited to just 2 declarations. Okay. Why this is a good question. Why the Typescript developers find that useful? Okay. So why? What is the motivation behind the Typescript authors of this library, this superset of JavaScript, to say, hey, we need to have this, right? Because there is another concept called the union discrimination, where it say, hey, if you have an object and you want to now, based on a particular value of that key, define the shape of the rest of the object, you can do that. Or if you want to define now is a limit set of key, which is restricting the key names here to that object, you can do that. All right. But all of this is to annotate objects. So, and here's the thing. Matt is mentioning Matt is mentioning that, hey, this is what we have here for types in interface. This is how you can annotate objects using types, and also do that with interface. And when it comes to now compose these different objects into more broad one, right? Which is part of the notions of the Typescript. When you look at the union types, this notion in Typescript that anytime that you need to define a declarations that describes a particular piece of a system or a business logic, that in the next 6 months it might change because we have to pivot from one market to another, perhaps, and when that happens, well, you need to find a way to enhance that, or to narrow those declarations, but based on this business demand, based on the real life world. Okay, so that's good. That makes a lot of sense. When I use types and interface, and when I want to enhance that description of the systems or a business logic as an object, you can do that is by using types and intersections, all right, or by using interface and extend. And this is quite, again, I'm trying to understand his intention of this particular code bases and people behind this thing, where they say it's like, why do we have types and interface? Why we just can only have is interface for describing all objects, right? Why do we have types here? And that's a good question. Because right now what you can do with types is to tell to JavaScript to compute these new types here, especially with intersections. Whereas with interface, you are telling to JavaScript to catch this definition. So I think that is based on this dynamic nature of the JavaScript. At the end of the day, that's what you have now, like types and interface. All right. But the difference here now with interface and types. Let me actually read the docs. I'm not gonna describe something wild here. Type inference, variable declaration, tiki. This is the handbook. Everyday types. The notion of narrowing here, of union. Type assertions, object types. What am I looking? Intersections. Okay, but this is the object types. Got it? The classes and the models, right? What I want to look is at the types. All right. Why do we have types? And why do we have now interface? So object types. In JavaScript, the fundamental way that we group and pass around data is through objects. In Typescript, we represent those through object types. So we have seen that we can be anonymous, like this, right? Or they can be named by using either an interface, exactly, or a type alias, right? In all three examples above, we have written functions that takes objects that contains the property name, which must be a string, and age, which must be a number. So quick reference: we have gseed available for the type, for both type and interface. And if you want to quick look at importing everyday syntax at the glance, yeah, let's take a look at this. Right, type sheet, cheat sheet, downloadable here, interface and types. Okay, so according to this is interface key points used to describe the shape of an object and can be extended by others. Almost everything in JavaScript is an object, and interface is built to match their runtime behavior. Okay. So interfaces are built to match the runtime behavior of the objects. And what about types? Exactly. Type versus interface. Interface can only describe object shapes. Okay. Interface can be extended by declaring it multiple times. In performance critical types, interface comparison checks can be faster. Think of types like variables. Exactly. Much like how you can create variables with the same name in different scope. A type has a similar semantics. Built with utility types. Okay. Key points. Full name in type alias and are used to provide names to type literals. Okay. Alright. Support more rich type system features than interface. So, okay, so 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 interface in TypeScript, according to the docs, is just to match the object's behaviors at runtimes. Whereas type, you can think of this like variables. You can also define here objects, okay? But when it comes to okay, but when it comes to provide, exactly. But when it comes to provide now, so is that in performance, critical types interface comparison checks can be faster. But again, the comparison, or in other words, the way how TypeScript analyzes interface and types, interface can be faster because it catches the definitions. Unlike types, where when you have to run intersections to compose more or to compose bigger objects that describe a particular state of your applications, whether it's an endpoint or a data that you're pulling from the database, some business logics, or some data that you want to show on the UI, right? So basic types are good, but if you need to somehow extend that behavior with other types, using interface, using intersections, this is something that TypeScript needs to compute, unlike interface, where now if you want to enhance the behavior of that objects, for example using extends, so behind the scenes is already catch that definition. So TypeScript knows that and where to look at that. So it doesn't need to compute that. Why this is important? For example, if you have now several types and you are now including or extending its functionality by creating an intersection of that. So of course now TypeScript, when doing this static analysis and on a CI/CD pipeline, it will take time to do that. Again, it's quite fast, but it won't be that fast as the interface, okay? Because it's already catch that. Okay. And also it says that support more rich type system features than interface. And those type rich features are, for example, adding dynamic keys here, okay? Which is map types, right? Adding dynamics key to that, or even adding conditions to the type of statements in holy hell types, okay, or adding conditions in types here. Holy hell, or template union types. All right. So for example, it's like, hey, I do want to add, or I want to create now a type that has this set of definitions here. Union types or template union types here. Hey, it can be int, and this is all the supported locals for this, right? Okay, and the intersection types and type indexing. Type indexings. Okay, a way to extract a name from a subset of types. And type tuple, and type from models. Type from functions. Okay, and if I look now, okay, that's a good look. And if I look now at the interface, alright, optionally takes property from existing interface or types. Alright? But again, the whole point of this is that interface wants to match the object's behaviors at runtimes. That say is how now these objects extend functionality, or you can create, or how you can how you can enhance this functionality in JavaScript. Alright, whether it's using the object.assign, or to using the spread operator to create a new object that contains all of these other keys and values from other objects. Okay, or how you can use this, the prototype change to actually derive or have access, particularly to other property and keys and values here. Okay, 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 okay. Holy moly! All right, all right. That's good. That's good. That's good. And also is that how you can manage is get and set in objects. That's right. Which is a behavior of an object. I need to look at the JavaScript behavior as well. Extension via merging. Interface and merge, so multiple declaration would add new fields to the type definition. And class conformance. Exactly, but with interface, it doesn't allow you to, for example, is define is union types or union literals or dynamic keys here. Okay, how you can describe is now in an object is dynamic key here. So again, types are feature rich. It allows you to define is, you can think of this like defining types of variables, right? Primitive or any basic types. It also have rich type features like union or like union type, union type, whether it's literal or other types. Adding dynamic keys to this object via map type. Okay. Also, you can add conditions. Holy fuck! You can add conditions to this object, right? Something that you can do with interface, right? But when it comes to extend the functionality of this type, all right, to mesh them together, it needs to compute that, and the way to enhance that functionality or data key and values on that object is using the intersection or the ampersand symbol. So it's going to enhance all of these objects, all right? But it have to do that at runtime. So Typescript needs to run that every time that it sees it. Where on live interface, it already catch that. But interface is not rich. But interface first. Interface are not type feature rich, unlike types. So in types you can, for example, have is union literals. You can dynamically add a key. You can dynamically define is a key. You can also define is restrictions to your keys. What is the possible value that this key might have? You can also add conditions to these types, which to me is that my bending, bro. You know. You can also add conditions to that, right? You can add conditional types. This is quite mind-bending that in the annotation thing, people in the Typescript or the developers that build this, they say, hey, you know what? We need to have conditional here, right? Okay. We can also now extract a key from an object known as type indexing, all right? A way to extract the name from a subset of types. You can also define tuples, all right, which is a specific behavior of arrays, okay, which is unlike a list, which is an unlimited amount of elements that you can have, but all of those elements must be The same, whereas a tuple, it is a fixed, well-defined collections where each one of those elements can be different. All right, you can think of this like a basket of, so you can think a list of a basket of the same apples. And you can think of the tuple of a basket of fruits, of different things. But it's defined, it's fixed. All right? And tuple type. Object literal types and primitive. Okay, okay. Did I answer my question of what is the difference between interface and a type? Even if I have to explain that to somebody else, is to say, well, types are, you can think of types like defining variables, right? You can hear with type is defines literals, values, types. You can also define union types. You can define tuples. You can define type index to extract the name of a, to extract a name from a subset of type. All right. You can also get the value of a type, or using a type of. You can dynamically add types as keys, describe that, and also describe what is the finite set of types, a finite set of key that you can have here, restricting the key, restricting keys. And the other is the conditions types here, which is pretty mind-bending, bro. Okay. And conditions types. This kind of behavior is something that you cannot have with interface. All right. So, because interface wants to mimic the behavior, all right. It is everything related to objects, and so interface is everything related to object, and it is behaviors at runtime. So that say is how you can now enhance how you can enhance these objects here with additional properties or data or functionality. Okay. How you can work with get and sets. How you can match the overloads, right? How you can also is merging object with the same name, which let me do this here. That's gonna define here is like, hey, let user. So here, what it's going to do, if you, for example, have this is now JavaScript. No, what the friend? No JavaScript. Say, hey, name, Joe, John, right? Age, 82. This is user 1. Name, age, address. And here you're gonna have is the zip code, some random zip code, and then you have now the street, right? And you say, hey, this is now Santiago, right? So if you do that, and then you say, hey, I want to now match the behavior of objects in JavaScript. So for example, I can create now a user2, okay, that will contain now is all of this property plus additional one. All right. I can say, is doing this. I can say object.assign the target with the additional, is the additional property here that I want this object to have. Let's say is now the script or mm, 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 how do I describe something to not be polemic? Yeah, name, age, address. Yeah, let's say I want to add something here to the address. All right. And then what I want to say is, or I want to do stuff this. Cell phone, right? Cell phone. Some random cell phone there. Cell phone, right? I do want to add this objects and enhance the functionality to this one, right? And then if I take a look at what the object is doing here with the user 2, right? Now I say, hey, I enhance the functionality. I enhance the description of this object that represents some piece of state in your system. Again, business logic or some API endpoints or some way to render the data on the UI. Got it. Holy moly. So this is how you can do this. There is another way to enhance that functionality. All right, to say, hey, user 3, it will have now this one. You can say, hey, you can use the spread operator. And that is username 1 and addition. So what it's going to do is this spread operator, what it's doing is to invoke. It's going to look if this is now an iterable. If this identifies an iterable, which is, hey, can I go over? So is this data structure is something that I can go over it? Whether it's collections, whether it's objects as well. So in the case of objects like this, right? And then I can replicate each one of those in this new object that I created. Plus, this one says cell phone. You got this. Right. And then I do want to show me what you have in memory here, right? You can see I enhance that, right? I enhance that. But this is the entire reason of the interface. So interface aims to mimic the object behaviors at runtime. And one of them is, how do you do this enhancement? Whether it's using data signs or whether it's using this, all right? And things like that. So it makes a ton of sense, right? And not only that, let's say you want to do something like this. I want to create now a user, an additional user here, right? What I do want to mutate or change is an existing object, which is or an existing key values like this, you know. You have to go to the address. You have to get all the way down to say, hey, the street here, right? It'll be now street here will be now is Buenos Aires, you know, street Buenos Aires, right? I do think I have additional object. Wait, what? why do I have this additional address street? Exactly, address street. This one. Why you say that? What French toast? Or why you think that it is? Exactly. Exactly. And exactly. And it's an unexpected token. Exactly, because you are now thinking something weird. This is address. This is the street. This is Buenos Aires, right? But you don't need this. Okay, no problem. What the French? Come on. This is address. So this is a street. Street is Buenos Aires, right? This is one object that is wrapping here, and this is another object that is wrapping here the address. And then I have I need a new one. And then a new one, like this, right? Yep. And it says something like that. What? Why is this? That interesting. So it's not able to do. Okay, if you have nested objects. Okay, if you have nested objects. You have to go with this. Interesting. Okay, so if you are going to add now a single object or a single property at that level, good. But if you're going to add now a keys on nested object, then you have to use the spread operator. Okay, again, this is part of the behavior, the expected behaviors on objects, and that makes a ton of sense, because this is how you can actually enhance the responsibility for that. All right. So another way to enhance that, right? Yep. Here we are with the same thing here. If you, for example, now wants to extend the functionality of a function here, right? Let's say you have now, let's go to now update the user one, right? It's gonna now update user one, all right? Or say something like this. This is now our user 5. It's gonna call claw, right? It is 26. This is the address, the same zip code, right? And it lives in, but that's that, right? Okay, got it. Good. And this is let user 6. All right. So if this object, for example, if I have now a functionality here, right, to say is some functionality here, let's say is favorite some functionality, exactly, some functionality here, Jesus, I was gonna call this yeah, some behavior, bro. Yeah, what kind of behavior will be? Say eating patterns. You know, so eating patterns, right? So this is now a function here. We're gonna define here as a function, right? And this function is gonna give me is, let's say, something like this, right? It's gonna just say, hey, well, this is what I have, right? Eating patterns. So lunch, and dinner, right? So on the user 6, right, I do want to add that, and the same for here, right? So if I go to console log of user 6, right, what I create here, not only that I can have access to the functions, and when I call the function is user 6 dot eating patterns. When I call the function, I'm gonna get that results, right? It's gonna run the computation here, and then something's interesting happened that go beyond the scope of today's video, which is the behavior of functions like closure and this, which are properties from functions. Okay. Okay, launch and dinner. Good. Yeah. Yep. But that's the whole point of this. And also how you can is defined in the case of user 6, instead of calling this, define this as a function, right? Yeah, something that go again beyond the scope of today's video. But this is the difference between one and another one. You can ensure a class conform an interface here. Okay. So right now, what we have looked at the object is that it say, hey, this is how you can extend objects in Typescript, whether it's using types, that's the reason why I'm looking at the everyday types here. All right, everyday types here. Yeah, everyday type here. Type annotations on variable. Yep, type annotations on variables. Exactly. So everyday types, right? Everyday types. That's what I look at the object types. Okay. How you can define now objects here, whether it's an interface, a types, or as a function. Okay. Some quick reference to go with that. And now how Matt, make ourselves familiar with these definitions and some example of how to do that, right? And also how you can now is do basic operations with types. Or you can now add some dynamic keys here, or even add the constraints to do so. That is quite useful a lot of the time for setting up configuration environments. Okay. And now an issue with duplicated interface, or in other words, this merging declarations.
Okay, so what you'll notice if you look at this quite closely is that we have two interfaces with duplicate names. We've got interface logger and interface logger. You would expect that these kind of behave as if they were JavaScript variables, where if we have two loggers with the same name, then these would error here, right? You would get a cannot redeclare block scoped variable logger, and this would fail at runtime too. I'm pretty sure, although I've never tried. And you'd think that's what happens here, but no. when you have declaration merging here, this is what this is called, you have two different declarations with the same name of interfaces, then they merge their declarations. So if I were to, for instance, add like an A string on this one and B string on this one, then currently my logger requires me to pass A and requires me to pass B. Look at that. So these declarations are getting merged. Whereas if I delete the one I don't want, and this is the one I don't want because it's got the excess parameter there, let's pull that off. Now I'm only required to pass B, and my error down the bottom goes away. So my logger.log now only requires a message string instead of needing message string level number. So you might be looking at that and thinking, well, that looks pretty...
Mm. 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 Mm.
Declarations are getting merged. Whereas if I delete the one I don't want, and this is the one I don't want because it's got the excess parameter there, let's pull that off. Now I'm only required to pass B, and my error down the bottom goes away. So my logger.log now only requires a message string instead of needing message string level number. So you might be looking at that and thinking, well, that looks pretty awful. Why does TypeScript let you even do interface declaration merging? Why has it allowed you to have two with the same name? Well, if you use type, then you don't have this problem.
Exactly.
Look at this. If we hover over this and it says duplicate identifier logger, it's going to warn you. It doesn't merge them. It just gives you an error and says duplicate identifier. But interface, it doesn't. Now, this will only happen when they're in the same scope, when they're in the same module scope. So if I declare an interface in a different file, which is in a module scope, then it's not going to interfere with that one. I don't need to worry about this cross-project unless I'm doing that deliberately, which we'll get to later. So it's only when they're in the same scope or you declare in the same file. But this is annoying enough that you might want to use types ahead of interfaces most of the time, especially if you're in long files, for instance. So yeah, like the reason this exists is because you need some mechanism of doing this, which we will get to later in this course, where we talk about kind of like global appending to interfaces like window, for instance. So we have, for instance, window is a global interface, and I can, if I want to, actually, where is it, interface? Yeah, there's the interface for window. This has a bunch of stuff on it, like documents and events, external, blah, 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 blah. And if I want to globally add things to the window, I need a way of doing that. But it can be pretty annoying as an application dev when you have just these two interfaces knocking about and they accidentally have the same name and you get some unexpected behavior. So this is kind of why I tend to recommend type as kind of like a default way of declaring object types. But then, of course, you also need to think about intersections versus interface extends, and there interface wins. So there's no clear winner still between type versus interface, but this behavior is something that should give you pause about using interface by default.
But for this particular behavior here that you have here, this behavior for function members in interface, because it's mashing all of that and it overloads, aka it creates these variants here. So behind the scenes, what it's doing is like creating is this it's like doing this. It's like creating is this one. This last one has more priority than the one. And if you, for example, do something like this, right? So again, this is part of the overriders here. Unless you comment that out and then you get rid of that, or unless you say something like this, and even though it doesn't solve that issue, because again, TypeScript doesn't know right now which you need to use, which are you using. It's just describing is all the possible combinations here, right? So if I do this, right, TypeScript doesn't yell at me, right? but it also say, hey, I can also pass a level if needed. But this is just to describe is the possible overloads or variant that these functions might accept. And depending of those cases, you might want to define some sort of descriptions there. You know? So for example, something like, hey, let me define some sort of description here for those overloads, right? In this case, to say, hey, let's say this logger version 2 handles only message, right? And if you do something like this, this is logger version 1 handles message and level, right? So it's at this level here, right, where you have to decide which one you want to go with. And here is not telling you it's not being descriptive about that. You know what I mean? It's not being descriptive here. That's kind of sad. So if I put it, for example, like this, will it describe that for me? Right? So if I put this here, okay, logger version handle, okay. Again, it won't tell you which one, all right, you are using it, but at least it will tell you is that here is the function that you're using. Logger version 2 handles only message, or if you pass now a number, let's say 3, right, it's gonna tell you that, hey, you are now using these variants. I think this is a one way to solve this interface, duplicated interface with functions member, all right, which is kind of interesting. Yep, kind of interesting on how to solve this. Yeah, for example, like this, you know. Exactly. So I think that might be one way to work around with that. But again, this is based on his experience. So, all right. I'll make a quick pause here. All right. Move on with the next one, which is working with partial data from a type.
In this exercise, we have a fetch user function. That fetch user function is calling fetch and going grabbing something from an endpoint called API user. And it's returning a type of promise user. That's correct to use promise because we're inside an async function. But this user type is not actually correct. Imagine that we're getting this interface user from like a shared group of types that represent our database, represent our data structure. We actually, in this function, we're only expecting to receive name and email. It happens to be like, grab something like from an anonymous source, let's say, or we're only getting a certain part of that user. Now, we want to represent this without changing our initial interface too much. We still want user to represent ID string, name string, email string, and role string. But we want to say this fetch user function only grabs back name string and email string. And of course, we could just like put name string and email string in there, but ideally we want them to keep up to date with the user if we can. So yeah, we just want a single source of truth for the type instead of having like multiple different names and emails scattered all over our code base. So your job here is to try to figure out a way to either change this interface inside the promise type there, or change the interface user to figure it out. And I'll say there are two different ways to fix this, or ways to find the solution. The first one is using stuff we've done before with interface extends, and the other one is with a new type helper called pick. Good luck.
So I can say now is, hey, I would like to define as an interface called user partial that extends from the user, where the only property that I want from there is name and email as it is, right? Which is now in a string, right? That's the only property that I want from this. So I can say, hey, now the resulting value of this computation will be user partial, or partial user. Right? It turns out that it say, hey, it is I expect name and email as string, and name. The type false does not satisfy the constraint true. Type false. What the fuck? Type false. Okay, the type user here does not satisfy the constraint here of name and email. All right. Oh, because user, since it extends from this, the interface at the end of the day is extending the functionality from. So instead of, so I can do something like this, and that it work. So what the extend is doing is to say, hey, let me now mash whatever you have, or let me now is get or access, allow you to allow this definition to access, in this case user partial, to this property and methods from wherever it comes from, right? In this case, user. So which is I don't want. I just want to get is the name or email, right? I can do this as it is, or I can use now. Another way to say is, hey, this is now defining is a type. You think you're funny? No, defining is a type and say, hey, I only wanna get is the partial, right? From, or another word is, I do want to get is from the user, all right? Yeah, it says, okay. So it says, hey, give me the property that you want to take on. Make all property T optionals. Okay, make all property T optionals. I don't wanna. Oh, this is make it all this property optional. Make this pick elements here. All right. If I say pick, right, and then I define is the user, and as the overload, it say, hey, key extend from the key of T. So in other words, it's saying, whatever keys I'm passing here, they already exist on this object that I'm passing to you, which is, hey, well, it is the name, and okay, it must be a name as a string, and the email as a string. Does it work in this way? It say no, it doesn't. Okay. What if I say name, for example? Will it work? It tells me, hey, name refers to a variable, but it's being used as a type. Do you mean type of name? No, I just mean is the values that I want to get from here. Oh, so name and okay, okay. Okay, you're using this as a value, as a name or email here. Right? So email here. Got it. Okay, cool. Awesome. So this is one way to run this. There is another one where you say, hey, using is map, which is wherever the user partial is, right? If this is now an object, so their keys, okay? So their keys must come from the type that I'm receiving here, and in this case it'll be is like this, which is in T. What I want is the key, my friend, right? These values will be is the key that are in these objects, okay? And therefore it'll be now a string, or it'll be is as the value from that the t value of that, or in other words, it'll be is the key for that, exactly, because this is the parameter, and now this is the no, it'll be like this, because now this is the key, and this is now accessing to that value that live in these objects. So this is one way to do this. Of course, it'll complain about, because you say, hey, what the French do you think you're doing? So in this use partial, I can say, hey, let me pass you now is well, for example, name, right? Or and again, this is a type, and those type can be is either is a type literal. Interesting. It can be either as a type literal or a single type, like any primitive, or a conditional type, or a union type, like in this case, an email here, right? So this resulting here, which is kind of interesting, right? Which is kind of interesting because here first I need to define is like in this shape. This is now the object that you're gonna get from, and this will be now is the key, the values were now keys. Keys are now in this object here, so they are part of that. All right. So key are key of this object or this type here. That T extends from an object. All right. Or you can simply say something like this. So T must be an object, extent of object, all right? So T must be an object, then now I make sure that T is an object, and the key must be anything passed to that. So in other words, I can say this is the user, and I can pass here is, that's interesting, key in. Key is part of the key of. Okay. Or in other words, this is key. So what if I want to say is key key so keys or this type, whether it's a type literal value, you know, this type must be part of the T. Or the key of. So you know what I mean? So it's complaining right now. Say, hey, duplicate T. And I say duplicate T because I just want to make use of this, right? You know what I mean? That's interesting. Or email. If I take a look at this key extend, okay. So T extend from an object, and key or this type extend in T, or extend from the key of, bro. You know? And extend from what am I doing here? That's a good question. A computer property name in type literal must refer to an expression whose type is literal type or a unique symbol. Type only refers to a type, but it's being used as a value here. Okay, I'm using this as a value. Okay, but key in T. and I don't quite follow here, because it say, hey, so this key must be in T. Okay, so this type, this literal type, must be a member key of this object. Okay. Okay, in T is not assignable to type string, null, or symbol. Unless I say extends from object. But even though I am quite lost here, because you're saying this key extends of this type, alright? And yeah, this key, so this key extend from the type, right? And then you define like a new parameter here, where you say, hey, this must be part of the key. Okay, it's like this type must be one of this member here. Okay, again, this is another way of how you can define this type using genetics of that, or just using is the pick for this. Again, something that I want to dig in later on, but that'll be all for this video. Take care. Bye bye.